here we go. So what is sine and cosine? Well, this is a stop sign, as you can imagine, because if you didn't get the joke, it's because you probably didn't know that the sine graph goes like that. That's what the sine graph looks like. Okay, so that's just a stop sign, you know, just dumb math joke. So let's analyze it a little deeper, though. At that spot, that's 0, 0. That means sine is 0 at 0. What are you talking about, Mr. Server? Okay, y equals sine of x. There's an x and a y, right? There's an x and there's a y. And that's the point 0, 0. So I can put in a 0 and a 0. Sine of 0 equals 0. You don't believe me? You put it in the calculator. Sine 0, it'll equal 0. But in case you don't remember and kind of like put it back to where it came from, do you remember doing circle trig? Do you remember me saying that circle trig would keep coming back? It's back. So you remember 0 is over here? That's where 0 is. So what's sine of 0? Sine is the y value. Sine is y. Do you remember that? So if sine is y, that's points 1, 0. If the sine is y, oh, look at that. Sine is 0. Okay, so that's a way you could have known that sine of 0 was 0. Because we're at 0 degrees right here, and we got 1, 0, and the y is the 0. Okay, so what's another spot? Well, this spot. Sine hits 0 again right there. So if sine is 0 also in the middle of the stop sign thing there, how do I know where that is? That says it's at 2 pi. In case you haven't caught this yet, they're numbering this way. 0, pi, 2 pi. What's exactly between 0 and pi? Right up there, that's at 1/2 pi, or pi over 2. Do these ring a bell? 0, pi over 2, pi, and then what's this spot here? 3 pi over 2. I was trying to get you that off that Schoology quiz. All right, that's a little messy. Let's get to a nice clean graph. Here's a nice clean graph. Notice we have 0 here. They don't mark it because you're supposed to know that that's 0, right? And then they got pi over 2, and then they got pi, and then they got 3 pi over 2, and they got 2 pi. You're going to write that sequence of numbers a million times, so I want to make sure you get what it really is. 0 pi over 2, 1 pi over 2, 2 pi over 2, then doesn't it make more sense that this is 3 pi over 2? And then this one is really 4 pi over 2. But 4 pi over 2 would reduce to 2 pi. 0 pi over 2, 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2. When you see it that way, they just make total sense. They're just stepping it up by 1/2 of a pi. Okay, then what's the graph look like? The graph of sine. We know that sine of 0 is 0 because do you remember from circle trig? Well, let's get all 4 of them then. These are the key spots. Here's pi over 2. Here's pi. Here's 3 pi over 2. And then 2 pi is actually wrapped around to 0 again. So this is 0 or 2 pi. Okay. Then the points. There's 4 points. At that point, it's 1, 0. And remember, the sine is the y value of it. Starts at 0. This would have the point right here of 0, 1. This point right here would be at -1, 0. And then lastly, the point down here would be at 0, -1. So sine is going to go like this. 0, and then it'll hit 1. And then it'll hit 0, and then it'll hit -1. And then guess what? Starts the cycle over again. Goes to 0, and then 1, and then 0, and then -1. So that's what it does. Starts at 0, and then it goes to, at pi over 2, it goes to 1, And then at pi, it goes back to 0. 3 pi over 2 goes down to -1. Pi over 2 goes back up. There you go. That's what sine looks like. Now, I took a lot of time telling you why it looks like that, but now you just have to know it looks like that. Did you know that sine and cosine are a lot alike? Don't they both go up and down? They go to as high as 1 and as low as -1, and they just go back and forth. They're a lot alike. They're not perfectly alike, but they're a lot alike. Well, cosine is the x value of all those points. So it starts at x is 1, and that means that the cosine at 0 is 1. Cosine of 0 is 1. So let me go down to the graph. Here's cosine, here's where the 0 is, and it's at 1. Starts there. At pi over 2 is up here, and the cosine is the x value, so it's 0. 0. I hope you see where this is going. It's going to go down there, and then it's going to come back up, and then it's going to go all the way back up to the top. And at 2 pi, it's going to be 1 again, because 2 pi is right here, and the cosine of that is 1 again. So it's just another wave. It's just, I like to think of this as a valley. Do you get it? It starts at the top and it ends at the top, and you went down into the valley. And then you back up. All right. Now that complete cycle, that is called one period. Okay, so when you start and then you end at the same exact spot that you ended, or that you began, like you started here, you ended here, that is called one period. How long did it take to complete a cycle? 2 pi. So this thing's period is 2 pi. How long does it take cosine to complete a complete cycle? Well, again, you start somewhere and you end at the same place. So if it starts at 1 and it has to end at 1, okay, and if it does its complete cycle, it goes all the way down, it comes all the way back up, it does it at 2 pi. So it's over the course of 2 pi. It's like time. You know, wouldn't time be on the x-axis? It's kind of like time. So how much time does it take it? From 0 to 2 pi, so 2 pi. So its period is 2 pi. How about its range? The range is the up and the down, right? The range, you usually say from low to high. What was the range of cosine? From -1 to 1. What was the range of sine? From -1 to 1. Their ranges are the same. What's their domain? Their domain is from left to right. And you're only seeing part of it, but do you get that these actually continue forever? They keep going. They keep going forever and ever and ever. So their domain is all real numbers. They just keep going. All right, now you know a little bit more about the graphs. What's the main thing? You're going to forget which one's which. Try to remember that sine starts at 0. Because the cosine won't. If you can just remember that sine is the one that starts at 0, this is the start of sine. It starts at 0, 0. Okay? And sine is the most fundamental trig function. It's like the boss. You know what this whole family of functions is called? Sinusoidals. Because you know what cosine is? It's just a bad copy of sine. It's sine except shifted. You know what tangent is? It's just sine divided by the bad copy of sine. Sine over cosine. That's what tangent is. So all the other ones depend on sine. There's really only one wave. The rest are just imitators. It's kind of like Coca-Cola. It was the first pop. And now there's a million of them, but they're all just imitators of Coke. In fact, in some states, if you ask for a Coke, they want to know, well, what, you know, that doesn't mean Coke. It means a type of pop. All right, so anyway, my point, sine is the original, and all the other ones are just kind of like sine. All right, let's move on. There's this page, which talks about the domain and range, which I just told you. And notice it's continuous and smooth. It just kind of keeps going, and there's no jagged edges. There's no like abrupt stops. It just kind of is smoothly traveling across the graph. Now cosine is even and sine is odd. Now that's weird. You're going to have to like get used to that one. That feels wrong to me because sine is kind of like the original function and it starts at 0, 0 and it all makes sense, but then you call it odd. Later you'll understand why, but for right now, just try to remember that cosine is even and sine is odd. They both have a period of 2 pi. I showed you that part. Okay. A thing called amplitude, and amplitude's kind of a big deal. The amplitude is how high the wave goes. I'd like you to think of this as water for a second. Can you imagine if this is like a really wavy day and then just somebody like put their hand out and said stop and all the waves just stopped and then it went back to flat? Do you get that the water would just go to that dotted line? If this was all water, it would level out right there, okay? Because there's high spots and low spots, but they would all just level and go flat, okay? So the amplitude is this distance. It is not this distance. Some people think it's the whole distance. It's not. Now, I actually looked into this to find out how surfers, my name is Server, which is usually the autocorrect changes to surfer. Anyway, so I looked up and saw what surfers do to measure the wave height. I would have thought they'd measure it this way, and oddly, there is debate. So it isn't even standardized in the surfing world whether or not you should say that the wave was this high, which is what we do in trig, or whether the wave was this high. So it's not a standard always this answer, okay? Because you could do it either way. It obviously makes it sound more impressive if you go it this way. But just so you know, amplitude is going to be measured this way, from the middle up. Okay. So if you have a function that looks like this, y equals 3, I'm just going to write you one. Y equals 3 sine of 2, change colors, 2x minus pi plus, let's say 4, because I haven't used a 4 yet. There. Do you get this as just a sine graph that's been messed with? They did a lot of stuff to it. They stretched it, they moved it, they shifted it, they moved it left or right, and they moved it up and down. Okay, so let's talk through what they actually did. That 3 in the front, that'd be a vertical stretch, but it's also the amplitude. You know that distance from the middle up? That tells you the amplitude. Okay, next, the B term right here, that is going to tell you your horizontal stretch or shrink. But we have this little saying for B. The period is 2 pi divided by B. That's what's special about B. That the period will be 2 pi divided by that. So if there's a number right here, normal sine would have a period of pi. This one's period will be 2 pi. Sorry, normal? I think I said that wrong. Normal sine has a period of 2 pi. This one would be 2 pi divided by 2, which means its period is only pi. It gets the complete cycle done faster. It gets it done across just pi instead of 2 pi. So that affects how it's horizontally shrunk. And the key, that equation, got to know that equation. And you know there's been a lot of units lately where we've been giving you the equations. We're not giving you that one. Promise. Like we never have. So I can't imagine we do it this year. Although, you know, it's pandemic, so who knows. But you should memorize it anyway. Period is 2 pi over B. Okay, next thing is this guy, and that's a shift. But when you're in trig world, you call it a phase shift. And notice this has been factored. I'm going to make these red parentheses. The 2 got factored out of that. So the phase shift is that. And phase shifts are directional. If it's minus, it's to the right. That's normal. You're used to it that way. Everything on the inside of the parentheses, you always can't trust it, you know, and negative seems like it should go to the left, but it actually goes to the right. So that's a phase shift right pi. And last but not least, this also got moved up 4. And that's everything I have to teach you. And since my iPad is about to die, I am going to hit save.